Hey everyone, welcome back. If you have ever had a Spark job stuck at 99% because one task just won't finish, you have probably run into a very common issue, that is data skew. And today I'm going to show you how to fix using a simple but powerful technique, that is with help of salting. So what is data skew? Let's imagine we are at a restaurant with 10 waiters. Each waiter handles people based upon the first letter of the last name. Sounds fair, right? But now imagine 100 people walk in and they all have a same last name, that is Smith. One poor waiter has to serve all 100 customer with named Smith while others are just chilling. That's what happened in Spark when you join or group by a column like customer ID and the most of the rows have the same value. This problem is called data skew. Spark processes data in parallel using multiple tasks, but one task gets most of the data. That task becomes a bottleneck. That's when executor may run out of memory and it will take longer than others and your job stays stuck forever. This can happen during joins, group by, reduce by key, or any shuffle heavy operation. So, how do we solve it? We use a trick called salting. Think of salting like giving each customer Smith with a different ticket number, that is Smith 0, Smith 1, Smith 2. This way, we spread the crowd among multiple waiters, not just one. Let's understand with help of a simple PySpark example, but start with creating a Spark session. Say we have a orders table. It's big and most of the records have the customer ID 1. We simulate the data skew by creating 1000 orders for customer ID 1 and 100 records for other customer. Next, we have a small customer table with just a few rows. We start with sorting the big table. First, we sort the large table orders because that's where the skew exists. So, starting with setting up the sort key with value equal to 3. Next, we generate a random number from 0 to 2 using the random function and floor function. That's what our sort. Next, we create a composite key called customer ID sorted. For example, if customer ID equal to 1, we randomly make it 1 underscore 0, 1 underscore 1 or 1 underscore 2. This splits the overlooked key into three smaller buckets. So let's complete the code. So in the output, you can see every customer ID is being sorted with value underscore 0, underscore 1 or underscore 2. Next, the small customer table does not have sort values, so we have to manually duplicate each customer row across all sort values. We create an array with value 0, 1 and 2 and then explode it, meaning we stretch each rows into 3 copies with value 1 underscore 0, 1 underscore 1 and 1 underscore 2. This ensures that no matter what salt was randomly assigned to a customer in order sorted, there will be a match in customer expanded column. So let's complete the code. So here you can see in customer table, the customer ID column is being exploded into three rows with value underscore 0, underscore 1 and underscore 2. Finally, we do the join on the sorted key, that is customer ID sorted. Since both table now use the sorted keys with orders sorted has 1 underscore 0, 1 underscore 1 and 1 underscore 2. Similarly, customer expanded has all those keys too. Each record will now find a match without overloading any one task. So the result, the Spark job is evenly distributed. No more slow Stangler task, no more 99% stuck jobs. Now there is one common question, why not solve both the tables? Well, the whole idea is to break up the heavy side. If you solved both, your join keys won't match. Instead, you only sort the big table and then duplicate the small one with matching sorted keys. It's efficient and safe too. Now let's wrap it up with a quick checklist. First, what we have done is added salt to the large skewed table, and in step 2 we have duplicated the smaller table with the matching salts, and in step 3 we have joined using the salted key. This technique avoids memory issues, speed up joins, and keep your Spark cluster happy. At last, thanks for watching and see you in the next one.